Yeah, I discovered last year when we were setting up for field day that the brewery gave away free beer at noon. And I was surrounded by people, we were putting stuff up and everybody was working. All of a sudden, about 2-3 minutes after 12, I was the only one there. I had no idea what had happened. So let me see if I can get this PowerPoint drawing thing started. Yeah, I decided to use my own photography for my background stuff. So that was a part of the Miramar Air Show. Let's try this one. Thank you, Mr. Gates.
Don't worry, it'll all clean up in editing.
Okay, yeah, that's what I pushed was F5. Should we try F5 again? That must be the other F5. Okay. As a lot of you know, I'm a design engineer at one of the companies down in San Diego. And as a result, we get visits from a lot of the different suppliers. And I was fortunate enough to talk to the UHF, VHF, RF specialist for a company called Microchip. And they flew a guy out, his name is Steve Bible. And Steve is a unique character, he's a ham. And he's probably a far better instigator than anyone else I've ever met as to getting things started. And he's personally responsible for getting me in all sorts of trouble. However, we were sitting there discussing, what were we discussing? 433 megahertz, part 15 garage door opener type transmitters. And he goes, hey, I'm the vice president of Tapper, and we're doing the Digital Communications Conference tomorrow in LA, and you got to drive up. It was on a Friday, so I had to take the day off work. So I was, oh, day off work to drive up and play with radios? Yeah, okay. So I took the day off, drove up to some little hotel. He's found that number one with this group is everybody has a notebook computer and everybody runs RF LAN. So order number one for the hotel is you got to have 802.11, it's got to be free. So we usually stay at really fancy places like the Clarion. This year was at the Clarion also. And there's a conference that they have, and it's called the Digital Communications Conference. So he introduced me to this group called Tapper, the Tucson Amateur Packet Radio Group, and it's actually a corporation. And a lot of really interesting characters. And for me, you know, I always loved experimenting with stuff and playing with different things. So for me, I fell right in with these characters. So first thing I wanted to do is tell you a little bit about what the organization is for. Originally, it was some guys in Tucson. It turns out that there's still a couple people from Tucson, but there's mostly people from all over the world. And their whole auspice is to support research and development in areas of digital communications across amateur radio. And furthermore, they have a really good website which they disseminate all the information on packet radio, digital communications, and all the little things. The very last slide is all the URLs. He's getting his paper out already. The very last slide has the URLs for everybody. And also, for those of you who miss the Heathkit days and being able to build little things, they supply all sorts of little kits. And as a matter of fact, one of the big debates that came up this year is, do you or do you not solder the little bitty surface mount stuff for them before you send the kits? And Unfortunately, one of them, they really wanted to get out right away, and so they sent, like a half a dozen guys over to Microchip in one of the R&D labs to sit there and hand solder FPGAs down onto boards so that they could get these kits out in time. So you'll know those guys because they all have the canes with the white tips on them. And of course, the fourth bullet down, to pursue and help advance the art of communications. These guys did the first TNC here in the U.S. They were instrumental in APRS, obviously Packet, X.25, you name it, they've had their grubby little hands in most of it. And by grubby little hands, I should note that Paul Williamson has been a member since 1984, far longer than I. And he promised to come here and heckle me, so I figure I'm firing the first shot.
May regret it.
I got a microphone and you don't. Anyway, and of course they also provide a lot of publications and things on their website. And one of the things I found out is in order to raise money, they sell them. Bad news. However, if you go to the meetings, there's usually somebody there with a photocopy of it. All right, so things we got to talk about tonight. A little bit about the history of the organization, a little bit about what everybody calls the DCC, the Digital Communications Conference. Some of the kits that they have put together for those of you guys who are interested in putting stuff together, some of the projects they're involved in. And then a little bit about something that's near and dear to my heart, software-defined radio, which is kind of a cool thing. And Paul has brought a software-defined radio with him and has it running back there. Unfortunately, can't get anybody on 20 meters inside the building here tonight, but you can go look at it and say, yep, there's no signal there. But it works. Anyway, and then turns out that a lot of people in the DCC and TAPR are also members of AMSAT. As a matter of fact, I don't know whether I'm supposed to say this or not, so none of you guys tell anybody, okay? I was talking to Steve Bible the other night, and at Dayton this year, or every year, TAPR has their little party in the evening, and AMSAT has their little party in the evening, and they can never agree on a restaurant. So as a result, all the people who are members of both groups, myself included, have to figure out which one they're going to go to, and we usually get upset and don't go to either or something like that. My daughter informed me that she's going to Hamvention this year, and the reason why is I told her Steve managed to reserve the National Air Force Museum at Wright-Patterson Air Force Base for the dinner. And then afterward, the Air Force Museum is open to roam around until they throw us out. We're not quite sure when that's going to be. So, really cool thing. So, besides getting these two groups back together again, you get to play in the Air Force Museum for the night. Okay, let's see, and then the last one, next steps, those are the URLs. I took this right off the beginning. Can everybody read this? I don't know whether it's, can you read it at the back? Too small, too large? I can make it smaller. Oh, wonderful. Let me see if I can turn off this display and maybe it'll. All right. I'll go ahead and read it. This was just basically the night they started. And it was 6 guys all together. And it said, after several hours of transmission of test packets, Lyle Johnson, WA7GXD, successfully initiated the first amateur packet radio contact with All-American hardware and software using the Tucson Amateur Packet Radio Terminal Node Controller, or TNC, at 9:12 p.m. Pacific Standard Time, June 25th, 1982.
UTC.
Pardon me? That was before you were born, I understand. Anyway, they decided that was too cool of a thing to leave laying about without telling anybody else, so they did whatever else they figured they'd build a kit. So they built a kit, and they sold it as TNC1. And what everybody was so proud of is that when you got a kit, you had this custom simulated leather plastic brown binder that was like 2 inches thick with every piece of documentation that anybody ever thought of regarding TNCs. And they have kept they must have, when they did this, they must have ordered like 100,000 binders. Because to this day, this year at the Digital Communications Conference, people were walking in with these binders still. And they noted that they haven't put those on the kits in years, but the binders are still around. Anyway, the Digital Communications Conference is, since this group basically isn't in Tucson anymore, moves from place to place. They typically go East Coast, Midwest, West Coast, and back again. But this year was special. It was the 25th anniversary, so they went back to Tucson, where it all started, and managed to scrounge up most of the guys who did the original stuff 25 years ago, and had a big banquet and got them all up in the front. And I thought about including all those tons of pictures of all those guys that kind of look like people in our club standing up in the front, cutting, the cake and standing there with their plaques and things. And I thought, well, why bother? I mean, you don't know who any of these people are, and Paul wasn't up there, so. Anyway, so I didn't put all the pictures of all the guys standing there. But anyway, basically what you do is you sit there for between 2 and 3 days, and you get little presentations. They're, hour and a half long, where somebody has come up with an idea for something cool that either they've done, they'd like to do, they're in the middle of trying. Most of it's on VHF, UHF. A lot of it's digital, some of it's satellite, and we'll go into some of what they've been up to this year. Okay, things that they did this year. Of course, one of the hot topics was software-defined radios. We'll get into that in a minute in a little bit more detail. How many people know what D-Star is? ICOM's D-Star. Yeah. ICOM is supporting basically cell phone type technology, digital audio, up around 915 megahertz, and there's a ham band up there for those of you guys who, besides Art knows where it's at, because you do your ATV stuff up there. But there's a band up there, and ICOM is doing digital audio transmission, and now they're expanding out to just about everything that you can transmit digitally. So for those who are in the public safety, it works a lot like the 800 megahertz radio system. Let's see. Digital voice, digital satellite communications. We had Steve Bible talk a little bit about a kit that he's doing that takes GPS information and allows you to get precision timing for verifying frequencies, setting up frequency counters. Just gives you a really nice, accurate time base. We had a couple of people talk about APRS. One of them was cool things that can be done with that. How many bytes is it? It's like 47 bytes or 52 bytes, something like that. Paul, do you remember how many? No hard limit? The 40-something byte little packet area in APRS, and cool things that can be set there. As a matter of fact, the guy who did it, that discussion, was the father of APRS, who showed a really cool thing that he did with using the APRS for DOS program that he wrote and doing T-hunting back out just outside of Washington, D.C., trying to find somebody. And he would just call around and found a bunch of hams, and they would listen for this signal and report the number of S-bars. And he would go to his little APRS program and would sit there and it would draw overlapping circles. showing who could hear and how well and how strong it was, and eventually he found the guy that way. So I thought that was pretty cool. A lot of people talking about digital signal processing in the HF modes, you know, PSK31 and variants of the digital modes for HF. There was a discussion on mesh networking and peer-to-peer, mostly for PC type thing, but you know, hams will experiment on the bands they can experiment on. So they're experimenting on the ham bands. One gentleman had a AX.25 forward error correction algorithm that he was proposing. And it looked neat. Basically, AX25 is a communication standard for digital communications over radio, right? And the problem is that if you get an error in the packet, you know, then you got to go back and retransmit. And what he did is came up with a compatible method of forward error correcting. In other words, sending a bunch of additional bytes and then burying the AX.25 packet in the middle of it so that it could correct errors in the packet without having to retransmit again. So it's kind of a cool thing. That's the upside. The downside is that it made the packet really, really long. And so you might have actually had just as good a chance of getting an error because the packet's longer. But, you know, once again, that's the place to present this stuff. And lastly, a lot of people did discussion of what they want to put on the AMSAT Eagle project, which is the next satellite that AMSAT wants to put up. One of the first guys to talk didn't even give a paper, and he was kind of a last-minute thing. But I just wanted to show you how far it was. They asked him if he could help out, and he flew up from Australia to describe in detail a system that he developed and then started a little company, and he found he had a friend that was into sailplanes, gliders. And they have these contests where they'll get 1,000 gliders trying to go from point A to point B, all riding the same sets of thermals along a mountain ridge. And they tend to run into each other, and that's, you know, the front end of a glider is that big concrete weight. So that's pretty hard on the wings of the other gliders that are nearby. So he came up with this GPS collision avoidance system, uses a pressure altimeter. It's a little tiny portable box that requires just 12 volts, and he uses Velcro, stuffs it on the dash, and they can be removed. Some of them he has to run an antenna someplace depending on where it's stuck at. And it's got a compass rosebud on the front of it. And if nobody is within, I forget the distances, but if nobody is within its range, all the LEDs in the rosebud are off. Somebody gets a little closer, they turn green. You get a little closer, they turn orange, then they turn red, then they flash. And then I was joking with him afterward, and I said, and then right after that, the little box jumps out of the plane and parachutes out. Oh, I forgot to say, and the thing beeps and screams at you. And it, obviously, the rosebud shows where the other vehicle is. And the reason why he thought this was interesting to ham radio is because he had developed the communications and collision standard for how these guys pass all their traffic back and forth, and a little mesh network so that if somebody isn't talking to somebody, it will route around, and eventually the data will find where it needs to go. So it was a great way to get things started. It was a lighthearted discussion about not running sailplanes into each other at 8 o'clock in the morning. Let's see. A little bit later they were talking, we already talked about some of the data handling discussions, such as mesh networking. Proposed adjustments. How many people here deal with APRS? Yeah, there's, you guys are familiar with the infamous number of hops, setting the number of hops. It turns out that in Los Angeles and Houston, they're having a lot of traffic problems, and they've got people now that just sit there and record the APRS traffic. And they go in, and instead of hooking it up to a radio, they hook it up to a tape, and they sit there and they play back the traffic, and they try different collision scenarios. And to see, you know, what propagates garbage down the network and what tends to quiet down. And so they gave a big, long discussion of what causes traffic to crash into each other and what cleans the thing out. And as a result, they had 2 or 3 suggestions on how to modify APRS, and that's all being disseminated now. One of the guys had something called MicroSmart Digi. It was a product that he designed and is now trying to market to the ham community. And of course, it's a little APRS digipeater, and for places where you can get up a little higher and get APRS signals from place to place. And then he decided it would be kind of fun to do something else with it, so he made it a gateway so that you can talk to D-Star through APRS, which is kind of a cool little idea. We had, I don't know if you know this, the next satellite, AMSAT Eagle, I'm ruining my own lecture, is going to fly a lot of new types of radio here that haven't been flown on the past satellites. So there was big discussion as to, can we set up an AX.25 satellite network? Would AMSAT be interested in doing it? And the guy who was giving this discussion was from the Naval Academy in Annapolis. And he's been flying these little Coca-Cola can satellites. And I'd never seen one before. Am I missing something good, Art?
Naval,
Oh.
Naval Orange Academy. It'd be
All right, so 3 o'clock this morning, I didn't know which naval it was.
But you were gazing into it, right?
Yeah, I was gazing into it. Yeah, good thing he isn't here. Okay.
Good sport, good sport.
Anyway, yeah, well, at least somebody's awake. I said that the length of this was going to be vastly determined by the amount of glazed over eyes. And when I see heads start to crash down, it's going to get really fast after that. Anyway, and then of course, just to prove that not everything was ham radio, oh, I was going to mention the guy from the Naval Academy. The coolest thing, he's making these little tiny microsats out of Coke cans. He takes and he cuts the tops off of Coke cans, has a little tiny homemade digipeater, and AA batteries, and the whatever astronaut happens to be loading this thing up pops the batteries in this thing, and he's got some way of sealing a piece of aluminum against the top of it. I don't know if J.B. Weld is space certified or not. And he screws a little antenna on, and they just kind of throw them out the side of the space shuttle. And this guy has the distinction of like launching more satellites than anybody else. And I got to thinking about it, pardon me? I got to thinking about it, you know, a Coke can is like the perfect shape because there's been a whole lot of time and money invested into just how little hardened aluminum can be used to make something that'll hold pressure and not leak. You know, it's probably the best canister that anybody ever thought of. I hadn't yet. Anyway, and the last discussion was on WiMAX 802.16 for those computer nerds in the room. Now, one of the other things that, that they talked about in there is GPS in general, doing timing stuff with GPS, and the ever popular, are there any other kits that we think we could make that somebody might be interested in actually building? One of the cooler ones, I think it was last year that they talked about that more than this year, was the vector network analyzer. So they've got a little kit. You can make your own little network analyzer on a PC board. If I remember correctly, it uses a Varactor tuner out of a TV set for generating the frequency sweeps. Neat ideas. Then for those people who are doing the temperature stuff with APRS, they have the little one-wire humidity and temperature sensor kits. This next one I put in just because it was something really, really simple that was easy to build. It's a DTMF squelch box. And it's a little box that you put together, and you run an external speaker on your radio, and you tell the little box, here's my PIN number, and the little box will squelch your speaker until someone keys your PIN number on the keypad, and then it opens the speaker up and you get to receive your phone call. So that way you don't have to listen to all the network traffic. Somebody just hits the tones for you, and it opens up the speaker, and now you hear what's going on the repeater. So that was a cute little thing. We had people that wanted to play with compact flash, use them in place of disk drives, and nobody made a cheap little adapter that looked like an EIDE disk drive on one side and a compact flash on the other. So they made it, and they're selling them. That one picture right there is one of Steve's creations. The universal synthesizer that can lock onto an oscillator. It's got an Altera CPL. And it'll, you can take a reference, 10 megahertz reference standard, and it'll synthesize and lock any frequency up to 1.1 gigahertz if you buy the prescaler, 245 megahertz I think without it. And it's, or to a 1 pulse per second from GPS receiver. So it just basically gives you a good stable time base. Now, they're very, very excited about a project that they're working on called HPSDR, High Performance Software Defined Radio. When we get into software-defined radios in a little bit, it's going to become relatively apparent that there's a bit of Achilles heel in the thing as to just how good one of the components is. And they decided that they need to design and build their own. So that's their first piece, is the backplane. And then they've got all the little cards and the power supply. They also made a little extender card so that you can now get the little boards up out of it. But so far, the only thing they've got is the backplane and the extender card. And they're all wildly trying to figure out what the rest of the stuff's going to be. Software-defined radio. My screen looks a lot like your screen, only mine's bigger. How many people here know what software-defined radio is? Well, I took most of that discussion. Okay, that's software-defined radio. Next slide. For the couple people who don't, the whole idea behind it is rather than having AM or FM or just about anything else, what you do is you say, well, I've got a PC. Soundboards are pretty cheap, so if I were just to take the RF signal, down convert it straight into something that I can feed into a sound card, and then I'll use the sound card to do all processing. I'll decide at that point whether it's AM, FM, single sideband, PSK 31, whatever it is, and then while I'm at it, since I can move my frequencies and I'm limited in bandwidth to only the bandwidth that the sound card can reproduce, I can look at great big sections and do spectrum analysis and just all the nifty stuff. So what they did is decided to make these things open source for the computer side of it. So now they've got just tons and tons and tons of people working on the software and pointing out each other's bugs. And as a result, they're getting some really neat stuff. And this just happens to be a picture of one of the SDR packages. This particular one is from Flex Radio Systems. Oh, we're going awfully fast. Because we're getting near the end. Last but not least, I expected to talk a lot more about software-defined radio. But since everybody went, yeah, I know what that is. Last but not least, there was quite a bit of discussion with AMSET's project, Eagle. As you're aware of, most of the previous AMSET projects were handled through the European AMSET group. This is the first project to be led by North American AMSET. So Pardon me?
Since 1989.
Since 1989. Thank you. I wouldn't want you to be quiet the entire time. Anyway, so I just got a little list of things that they want to fly on the next project, which will go up in space sometime around 1998, 1999, or whenever it's done. But they're hoping for a launch window somewhere around the end of 98.
Oh wait.
Oh wait. It's like naval. 2008, yeah, one of those years. Yeah. Okay. So, obviously, let's see, is there enough of this that you can actually read what they are? Yeah, you can read what they are. All right, so the point is, lots of transmitters, lots of receivers, fair amount of bandwidth, and as you can see, several of them are SDRs.
What are VUL?
Pardon me?
What does VUL?
Okay, those are the microwave, or they're the definition of microwave bands. And Paul, help me out. Let's see, C-band is around 4 gigahertz. Art?
It's a 5.8.
5.8. V is 70 centimeter, right?
V is 2 meters.
2 meters?
VHF.
Okay, then L must be 70 centimeter. No, okay, which one's L?
1.2 gigs.
1.2 gigs, all right.
U is 70 centimeters.
U is 70 centimeters. Glad one of you guys got it. Thank you.
S
Is the C-band bidirectional? They were originally talking S up and C down.
Well, this was as of this morning at about 9 o'clock. That's when I grabbed the last bit of the transmitters and receivers off their site.
But I would say the wideband was supposed originally was going to be, they were talking about it being receiving on C-band and transmitting on S-band.
Like I said, all I can say is this was current as of this morning at about 9.
I couldn't see the end of your screen over there, but at least U and blank.
Oh, and L. Common uplink shall be on at least U and L band receivers. Okay, let's see, what other wild and wonderful things can we say about AMSAT? I think, okay, for example, we've got a few items about this particular package. They want to keep it 100 kilograms or less. It's going to be spin stabilized between 1 and 15 RPM. Solar panels on the side, spinning around the Z-axis. One of the things that I don't have on here that I thought was pretty cool, I don't know whether they're going to do it, but it was one of the bigger debates, is if you spin stabilize this thing, you want it to have the antennas on the front side of the Z-axis pointing at the same place on the Earth all of the time. So one of the big discussions was, could they put phased arrays on the front of the satellite? And then as they rotate the thing, keep the phased arrays so that the beams point at the same locations on the Earth. It's a cool idea. There's people off trying to figure out if they can do it, and one of the cell phone guys who was doing a lot of time delay stuff on the cell phones goes, oh yeah, we built these really great chips that do just that, so we're going to go get some of those, and we'll give it a try, and we'll see if the smoke comes out. And so, who knows? We'll see whether or not they're able to do it. The orbit is going to be a high apogee elliptical orbit, so the thing's basically going to swing around the Earth real quick, and they say somewhere around 11 hours for the long part of the orbit, so you should have a good long chance at getting it. Was that the original plan for AO40?
Yeah, it's the same orbit. It's all a Russian orbit.
Not anymore.
Well, AO40 isn't quite.
Well, the Russian orbit, the only orbit is a high inclination orbit. We're going for equatorial high orbit this time. It's
Okay.
interesting. Different change from the old high orbit satellite.
Paul's information is better than mine. He just came back from San Francisco in the AMSAT conference. So I figure that he'll be joining me whenever we need additional information. As far as some sensors and interesting things, of course, we got the sun sensors to keep the sun keep the satellite in the correct location at all times. The earth sensors to look down and make sure that they still know where they're shooting at. There's going to be a couple of cameras that should be able to download video from the satellite. There's a narrow field of view camera on the plus Z and some wide field of view cameras on the minus Z axis. Let's try that one. All right. Everybody verify those frequencies are the right ones?
Yeah, this band showed up there.
Left one out.
Which one got left out? C?
S2.
No, S2.
Wow.
I'm not sure, you're nodding or falling asleep. Or
Nodding.
waiting for me to go to the next slide.
Yes. I'm nodding enthusiastically.
That's it.
Yay.
Yay! Okay, so places to go. Tapper's website, they list everything that they're up to, all the conferences. Rumor is they were debating as to whether or not they were going to be in Baltimore, Washington D.C., Boston. Everybody voted for some place that was had reasonable weather was the first concern. And then the second concern is a cheap hotel near the airport where they didn't have to take too many taxis. And also it had to have free internet. And those were pretty much the requirements. Had free internet, it was cheap, and it was near the airport, and it wasn't too cold or hot. For those of you who are interested in software-defined radios, there's the URL for the SDR forum. And then the last one is the longer one, rather than just going to AMSET's website in general. This is where you find the index for the Eagle project. And what's kind of interesting for those who may not want to be interested in working on the satellite specifically, but kind of tracking what's going on, this is what they're calling the first open source satellite. And it's not really open source as much as they've decided to take all of the project plans and put them all on the website. And so if you want to go look at, right now the preliminary designs for the magnetorquers are in there. Great big magnets, and when they get to a certain part of the Earth's magnetic field, they kick on these magnets and they use it to steer the location of the satellite by bucking the Earth's magnetic field. So if you want to see the preliminary designs, you go into the index, and you go under stabilization or something like that, propulsion and stabilization, and then you go look at magnetorquers, and sure enough, there's some PDF files of what the prototype magnetorquers are supposed to look like. Right now, there's this enormous tree and not a whole heck of a lot of data. Hopefully, by the time it flies, that'll all be filled in. Having said that, are there any questions, comments? Anything else? Paul, you want to add anything?
Millions of things, but we'll leave that for another time.
All right. Okay, well, in that case, thank you very much.